Hello, good morning. Welcome to today's class. Okay, so we can start. Good morning, everyone. Welcome to today's class. So today I'm going to look at waves. Waves as a topic. In physics, we have waves classified as a topic. We have so many things to look into as waves. We have propagation of waves, we have types of wave, we have classes of wave, and progressive wave equation. We equally have ways of producing waves. Okay? Now, if you look into waves, what are waves? Looking at waves, let me do a small illustration. Get a bowl filled with water, then you throw a stone into it. What is going to happen? You're going to realize that the water is going to move. It's going to move, sorry, make some movement. Okay. Now, as the water is moving, after a while, it's going to return back to its normal state. Do you understand? Okay. Now, that movement that the water makes is what we call displacement. That's what we call displacement. Okay. Now, the stone has disturbed the state of this water. Do you understand? Now, after a while, it's going to return back to its normal state. That means that disturbance is not what? Permanent. It's not permanent. So let's look at the definition of wave so you can understand what I mean by that. A wave is a disturbance which travels through a medium, transferring energy from one point to another without causing any permanent displacement of the medium. Now, from what I said, this wave is a disturbance. It travels through a medium. Now, as it's traveling through a medium, what it transfers is what? Energy. Okay? It transfers what? Energy from one point to another without causing any permanent displacement of the medium. Okay? Now, the process in which this is done is said to be wave motion. I hope you understand what I explained. Now, are we done? So we can proceed. Are we done writing? All right, are we done so I can explain? Are we done writing? Are you done so I can explain, please? All right, there are two classes of waves. We have what? Mechanical waves and electromagnetic waves. Mechanical waves are waves that requires a material medium for their propagation. Okay, so we have examples of mechanical waves. We have water waves, the sound wave. We have waves on a rope. Now, if I want to explain this water wave, let me come closer. If I want to explain these water waves, okay, it means that it requires a material medium for their propagation. How? Now, these waterways, there are ways that requires material medium for their propagation. Example, when you carry a stone and throw on the ground, you're not going to experience anything because there is no medium for it to take place. But get water, fill inside a bowl, then you throw what? Stone into it. That becomes a disturbance, okay? Now, that disturbance affects the state of that water. Do you understand? Now you can see the water making some movement. Some will go through this side, some will go to the other side. Then after a while, it's going to return back to its normal state. So that is what it means, that the disturbance is not permanent. Then after some time, it's going to return back to its normal state. Do you understand? So what am I trying to say? That water is a medium for water waves to come through or for water waves to occur. Is that clear? Now coming to sound wave. Now it's also a mechanical wave because it requires a material medium. If you blow air into the air like this, you won't produce any sound. But when you blow air into a trumpet, which is an instrument, you're going to produce what? Sound. Do you understand? So for sound wave to come through, air is what? The medium, the material medium for sound wave to do what? To come through. Because if you pour water inside the trumpet, it's going to produce any sound. Do you understand? Okay, so that is what we mean by mechanical what? Waves. So let's go to electromagnetic waves. Electromagnetic waves are waves that do not require a material medium for their propagation. Example, we have the radio waves, microwaves, X-rays, gamma rays, ultraviolet, infrared, and etc. Do you understand? Now, these rays, these are radiations. They do not require a material medium for their propagation. Do you understand? For example, if you want to take up an X-ray for anything, maybe X-ray in any part of the body, you don't need a medium for it to get to you. Do you understand? They are radiation. They are not just wave. They are what? Radiation. And they all move with the speed of light. They move with the speed of light, okay? Now, if you're going to look into the difference between mechanical waves and electromagnetic waves, you're going to see that this mechanical wave, they move with a speed less than that of light. And also mechanical wave can also be transverse or longitudinal, while electromagnetic wave are always what? Transverse. I hope that is clear. All right, so let's go to the difference between mechanical wave and electromagnetic wave. All right. All right, are we done? So let me explain. Now looking at the difference or differences between the mechanical waves and electromagnetic waves. So let's go to the first one. Mechanical waves, they require a material medium for their propagation. Okay, so in case you're asked to differentiate between mechanical wave and electromagnetic wave, the first difference is this: mechanical wave requires a material medium for their propagation, while electromagnetic waves, they do not require a material medium for their propagation. Is that clear? Now let's go to the second one. Mechanical wave may be transverse or longitudinal, okay, while electromagnetic wave are mostly or mainly what? Transverse. So coming to this number two, what do I mean by transverse or longitudinal? Some examples of mechanical waves may be transverse and some may be what? Longitudinal. So you should know the difference between them. Now number three, mechanical wave, they travel with a speed less than that of light, while electromagnetic wave travel with the speed of light. You know that the speed of light is always constant and is given as 3 times 10 raised to power 8 meters per second. So this is the speed of light. Is that clear? All right. So, but if you're asked to find the relationship or the similarities between mechanical wave and electromagnetic wave, they both transmit energy or they both transfer energy from one point to what another. Do we understand? Even though they some may be longitudinal, some may be what transverse, but they all transfer energy from one point to what another. So that is one similarities between mechanical wave and electromagnetic wave. I hope that is clear. All right. Okay, so let's look at the types of waves. We have types of wave. We have transverse wave and what longitudinal waves. Okay, so transverse wave are waves that travel in a direction perpendicular to the vibration of the medium. Now look at the word perpendicular. I'll explain what it means. Okay, now it travels in a direction perpendicular to the vibration of the medium. Now let's go to the examples. We have examples. We have water waves, all electromagnetic waves. All electromagnetic waves are what? Transverse. Now, if I go deep to explain, let me explain what I mean by perpendicular. For example, this is water on its own. That means it is left what? Undisturbed. Now, when you throw a stone this way, okay? Now, the direction of the stone is what? Vertical. Now, the movement of the wave will now be this way. Do you understand? So you now see that the direction of the motion here by the vibration is this way. Now you cannot say what I mean by perpendicular. So any wave that occur this way are said to do what? To travel what? Perpendicular. Do you understand? And they are classified under transverse waves. So transverse indicates what? Perpendicular movement, or the vibration and the direction of motion is perpendicular to each other. Do we understand? So the examples of such wave, we have the water waves, and all electromagnetic waves are transverse. If I mean all electromagnetic waves, I mean both X-rays, gamma rays, radio wave, microwaves, infrared, and so on and so forth. I hope you understand that. Okay. Okay, so copy first. Let's explain. I have longitudinal waves. They are waves that travel in a direction parallel to the vibration of the medium. We have example, we have sound waves, waves on a spring or rope. Do you understand? So in this type of wave, we have this wave. The wave is coming this way, and the direction is also what? Coming this way. So they are said to be what? Parallel to each other. So such waves that are parallel to each other is said to be classified under longitudinal waves. I hope that is clear. All right. All right, so let's look at this diagram on the board. We have this is a wave, how wave moves. Okay, now look at it. Now this is a displacement of a wave. If wave moves, it's going to move in this way to form this is the toe and what fro movement of the wave, right? This is toe and fro. So there are some important things you need to know when we are describing waves. The first is going to be what amplitude. Now this is amplitude. Okay, from here to here is the highest maximum displacement of this particle. Okay, that is what we say to be amplitude. Now, this upper part or this maximum part is said to be what? Crest. Okay? And this other side is said to be what? Crest. Now, the minimum part is said to be what? Trough. Why this is one is what? Trough. Now, when you compare the distance between these two crests or two successive crests, it said to be what? Wavelength. Also, distance between two trough or two successive trough is said to be what? Wavelength. Do you understand? All right. Then one other thing you need to know is this. What is a cycle? You know, a cycle is a to and fro movement. Okay? A cycle is a to and fro movement of a particle. Now, this is to and what? Fro. When a body moves from here to here, cannot be classified as a cycle until when the body completes this movement. So this is half a cycle, another half of a cycle to make what? One cycle. You understand? So from what we have on the board, this is a cycle, and this is another what? This is another cycle. Do you understand? So this is a cycle, this is another what? Cycle. So this is to and fro movement is concluded to be what? A cycle. Do you understand? Okay, then the time taken for this particle to make this complete oscillation, that is to move to and fro, is said to be what? Our period. That is period, right? Okay, that is the to and fro, the time taken for a particular particle to make a to and fro movement. Now we also have what we call frequency. Frequency is the number of oscillations that this particle make in 1 second. That is frequency. If it takes this particle 2 seconds, if you take this particle like to make 20 oscillations in 1 second, it is classified to be what? Frequency. Do you understand? Okay. Then the next thing is the distance covered by this particle in a limited time, or the distance covered by this particle is measured and also the time is measured, is said to be what? Velocity. Now that means from here to here, the distance covered by this particle is said to be what? Distance covered by this particle divided by the time is said to be velocity or the speed of the wave. Do you understand? So these are the things we are going to be using to classify what? Waves. All these terms I mentioned are going to do the definition so I can understand better. Is that clear? All right. All right, copy. So let's explain. All right, so let's go to terms used in describing waves. We have what? A cycle. A cycle is a complete to and fro movement or oscillation of a vibrating particle. I've explained that before. When the body moves to and what? Fro, it is said to be what? A cycle. Okay? Or it is said to have completed a cycle. Number two, we have amplitude. The symbol for amplitude is A. So let me write A here, sorry. Write A in brackets. Okay, that is the symbol. This is the maximum displacement of a particle from its rest position. It is measured in meters. Okay, I told you that up part is the maximum displacement. All right, so we have wavelength. The symbol for wavelength is lambda. It is the distance between successive crests or successive trough of a wave. It is measured in meters. It is the distance between successive crests or successive trough of a wave. It is measured in meters. I hope that is clear. So let's move to the next one. All right, so let's explain this concept. We have frequency, the symbol is F. This is the number of complete cycles that a particle makes in 1 second, okay? So the unit of frequency is what? Hertz or per second. Now let's go to the period. Period is the time taken by a particle to make one complete oscillation. It is time taken by a particle to make one complete oscillation. Now, it is measured in what? Seconds. Okay? Wave speed, the symbol is V. Now, is the distance which the wave travels in 1 second. It is measured in meter per what? Second. So, in a nutshell, I can say that frequency F is equals to the number of complete oscillation divided by what? Time. Do we understand? Frequency is the number of complete oscillation divided by what? Time. So, this is N over what? T. Now, we have the period is the time taken by a particle to make one complete oscillation. That is what? T over what? N. So looking at these two things, you can see there's a relationship connecting the frequency and what? The period. I hope you understand. So we're going to look into it in the next one. We are going to explain. And we have come to the end of today's class. I hope this video was able to help someone out there. Please don't forget to subscribe to this channel and turn on all notifications to get notified each time I post videos. See you next time in the next one. Bye for now.